This video is an introduction to ionic bonds and ionic bonding. Don't know anything about these things, or you feel a little bit rusty? It's no big deal, because we're going to start from scratch. So, ionic bonds are one type of chemical bond. Chemical bonds are like glue that holds atoms together. Okay, like here are two atoms that are bonded together. They're connected. They're glued. Now, ionic bonds are the type of chemical bond that hold together metal atoms with non-metal atoms. Okay, so if you look at a periodic table, there's this big, thick staircase over on this side. And this staircase separates the metals, which are all the elements on this side, from the non-metals, which are most of the elements on this side. So whenever we have a chemical that has a metal connected to a non-metal, that's held together by ionic bonds. So some examples are silver chloride, magnesium iodide, or aluminum oxide. Each one of these chemicals have a metal, this one, or this one from this side of the periodic table, with a non-metal, this one, or this one from this side. So ionic bonds in all these because there are metals and non-metals connected together. Okay, so now we're going to talk a little bit more about the how and why that's going on with the bonding here, right? It's like, how do these atoms actually connect together? What's holding them? That's what we're going to talk about next. Okay, so to learn more about ionic bonds, we are going to focus on a chemical called sodium chloride. Sodium chloride is a fancy scientific name for table salt. It's the stuff that you put on your food. So sodium chloride is made of two types of atoms. We got sodium. Here's its symbol from the periodic table, and here is a sodium atom right here. And sodium chloride is also made of chlorine or chloride. I'll tell you what the difference between those is in a minute, but you don't have to worry about it right now. And here's a chlorine atom. Now, sodium chloride happens when these two atoms come together, when they're glued together by ionic bonds. But the atoms that I have right here, they're not glued together. They're just kicking it over here. They have nothing to do with each other. So I want to talk about what happens to get these separate atoms connected and glued together, like these. How we go from this to this. I'm going to tell you the kicker. I'm going to tell you the end of the story now so you can follow it through as we talk. The reason why these two atoms are connected is because they end up getting electrical charges. Okay, this atom is going to end up getting a negative charge, and this atom is going to end up getting a positive charge. What do oppositely charged things like to do? They like to attract. And so because these things get different electrical charges, they are going to be held together by those different charges attracting. Okay, so let's look at the steps that we have to take to go from this to this. The first step is pretty much what I got right here. We're starting with two separate atoms that aren't connected. We got the metal atom, the sodium here, and the non-metal atom, the chlorine, over here. Now the first thing that happens on the road to an ionic bond is that the sodium atom gives one of its electrons to the chlorine atom. Here's the electron moving between the two of them from the sodium to the chlorine. Now this electron moving will change the charges of these two atoms. Okay? That's what happens in the next step. Sodium gives away one of its electrons to the chlorine, so it loses one electron. It has one fewer electron, and that's going to give it a positive charge because it lost an electron. But chlorine gained one of the electrons from sodium, so it's going to become negative. It's going to get a negative charge because of that extra electron. So now, these two atoms take on electrical charges. And what do we call atoms that have charges? We call them ions. This one's a positive ion, sodium becomes positive, chlorine becomes negative. Now here's where the difference between chlorine and chloride comes. Chlorine is what we call the chlorine atom when it's neutral. So up here, this non-metal atom, chlorine, just hanging out here, is chlorine, zero charge. But down here, after it's received one of the electrons from sodium, it gets a negative charge. It becomes a negative ion. And now we change its name just a little bit. We call it chloride. So it's the same atom, chlorine and chloride. They're the same atom. It's just chlorine is the version of chlorine with a neutral charge, 0 charge, and chloride is the version of chlorine that just has a 1- charge. And it got that 1- charge because sodium gave one of its electrons to chlorine, turning it into the negative chloride. Now people often ask, why does sodium give its electron to chlorine? We'll talk about that in the next video. It's a great question. But anyway, a transfer of electrons takes place between these atoms, giving this one a positive charge and this one a negative charge. And what do opposite charges like to do? They like to stick together. And so this is what we end up with. The two atoms glued together because their opposite charges are holding them together. Okay, so there are really 3 important steps in an ionic bond forming. For the example of sodium chloride, here's what they are. The first step is an electron transfers from sodium to chlorine. Sodium gives one of its electrons to chlorine. Sodium loses an electron, so that gives it a positive charge. This becomes positive. And chlorine, because it has gotten an extra electron, gets a negative charge. And they both turn into ions, atoms with a charge. And since chlorine became negative, we call it chloride. And then the last step after the ions form is that the oppositely charged atoms stick together because of their opposite charges. So it's those opposite charges that form that are the glue holding the atoms together. Okay, so this is just the very basics of how ionic bonds form. We haven't really talked about details, why the electrons move, and that kind of thing. That's what we're going to do in the next video. So to go a little bit more in depth, check that out. But before you do, just make sure that you understand these steps, these basic steps of how ionic bonds form. And then once you're good with this, we'll go from there.